Okay. Yeah, so I was saying, the last time we met, discussed the circles and the ellipse. And then from what we discussed, I believe most of you at least have an idea of what coordinate geometry is all about. Yeah, so from the circles, we're going to discuss the parabola and the hyperbolas. Yeah, so these are some of the things that you already know. More especially the parabola. The parabola is just a quadratic function. So this is very simple. So I'm sure I'm not even going to take a lot of time explaining this. Yeah, so I was saying last time I gave you an exercise. Yeah, so some few individuals managed to submit, though I didn't have time to go through your work. So I'll do is I'll go through your work tonight, and I'll make sure that I send you back your solutions, rather your marked scripts. Yeah, so if at all you have any problems, if I find out that you have any problem or you have any challenges, I'm going to make something like a tutorial where we're just going to be solving different questions about coordinate geometry. All right, so let's begin to discuss tonight's lesson. So whenever I give you an exercise, make sure that you submit. It doesn't matter what time I mark it, but just know that when you submit one day, I'll mark it. It's just that I have a lot of things to do, but I always make sure that I mark immediately after after submission. When you submit, I mark right there and send you back the solutions. That's if I'm free. Yeah, so in the previous week, I was a little bit held up. And by starting from the exercise that I'm going to give you tonight, I'll always be making sure that I mark the day when you submit. All right, so let's quickly begin to learn. So we'll talk about parabolas and hyperbolas tonight. Okay. So please just make sure that you mute yourself. Okay, just ensure that you mute yourself. All right, so when we talk about parabolas, so a parabola is a function that is as a result of a quadratic expression. Yeah, so it's something that looks like this. Let me show you. Let me just change the color of the marker. So it's something that looks like this. So it can either face this side or it can face this other side. Or, okay, let me not draw it like this because you might end up, mixing the concepts of hyperbolas and parabolas. So for parabolas, you have a parabola that has a maximum value, meaning it will come out like this when you sketch. And then there's also another one which has a minimum value, which comes out like this when you sketch. So in the same way, okay, let me say for these kinds of parabolas, the value, rather the term that is squared is the x term. So we know that a quadratic function is always in the format of ax squared plus bx plus c is equal to 0. So if they tell you to sketch this quadratic function, the solution always comes out like this or like that. So when x is the one that is squared, then you have your solution in this format or this other format. So now imagine that you have a quadratic function that is having y as a variable which is squared, meaning you have something like this. Okay, let me not do it this way. Let me do this. Okay. This side is not supposed to be a 0. Remember, when you're sketching quadratic functions, you're supposed to have a function f of, you're supposed to have either f of x this side or y. So this side we are supposed to have y. Y is equal to this function. And this is when you can sketch that. So now imagine that you have a function And this function, instead of having x as a term, or rather a variable which is squared, now in this case, maybe you have y. You have something like this, a function which is in the format ay squared plus by plus c is equal to x. Imagine that you have a function which is in this format. So now if you've been taught to sketch this function, you discover that instead of the curves facing either up or, either down or up, you have curves that are going to face either to the left or to the right. Yeah, so you have something like this. So these types of curves are the ones that we call parabolas. So parabolas will either, a parabola can face up or down, or it can also face on, towards the left or to the right. Yeah, so now let's take a look at some of some notes which I prepared. So some of the important features of a parabola are these. So in other words, when they ask you to describe a parabola, you're supposed to make sure that you list or you find or calculate all these things that have been shown here. So the first thing that you are supposed to find is the value of P. Of course, you understand what I mean when I show you the equation. Or let me just put up the equation here. So you are supposed to find the value of P after simplifying the expression. After finding the value of P, that value of P is the one that you use to find the directrix, which is the equation of the directrix. So the directrix is simply just this line which you are seeing here. So you find the value of P. It will help you to find the equation of the directrix and also to find the focus. So this value of P is the one that is going to help you find these two components of a parabola. Then after finding the focus and the directrix, you're also supposed to write down the vertex of this parabola. Yeah, so you're supposed to write down the vertex of this parabola, which is just the turning point. And then apart from that, you are also supposed to find the axis of symmetry, which is just the line that divides the parabola into two equal parts, which in this case is this line here. Yeah, so these are some of the things that you are supposed to find when they ask you to describe a parabola. So first thing, you have to find the value of P. The value of P is the one that is going to help you to find the directrix. Oh, yeah, the directrix and the focus. And then after finding that, you're also supposed to write down the turning point of the curve. Then you're also supposed to find the axis of symmetry. So all these are simple. So if you know how to sketch the graphs of quadratic functions, these are simple and straightforward. But one thing you have to understand is that the way we sketch these curves, it's a bit different from the way, from the process that we use, that we were using when sketching graphs of quadratic functions. So it's a bit, the method is a bit different, but we all come to the same result. Yeah, we all find the same answers. Whether you use that method or this method, you still find the same answer. All right, so there are some books which will also ask you to find the points at which the curve is meeting the x-axis. Yeah, so you can also find that if the curve is meeting the x-axis. All right, so let us, I think, look at an example. Okay, let us quickly look at one example. Okay, all right, before we look at an example, let me first explain something here. So what you need to understand is that when the value of x is the one that has been squared, I'm sure I talked about this. Now, let me just add some more information. So when the value of x is the one that is squared, then you expect your parabola to either face up or down. So now, how do you know that this parabola is facing up or it's facing down? Let me explain. So you know that it's facing up when the value of P is, you know that it's facing up when the value of P is positive. And you know that it's facing down when the value of P here is negative. So that is how you know that this curve is facing down or up. So you know that it's facing up when the value of P is positive, and then you know that it's facing down when the value of P is negative. I don't know if I've not interchanged them. So when it's facing up, yeah. So when it's, what's happening? All right. So I was saying, okay, let me just do this. Okay. So I was saying when it's facing up, the value of P is what? Is greater than 0. The value of P is greater than 0 when it's facing up. And then when it's facing down, the value of P is less than 0. So when the value of y is the one that has been squared, then you expect your parabola to either face towards the left or to the right. So when the value of P is when the value of P is the one that has been squared, so you expect your parabola to either face to the left or to the right. So it will only face towards the left or the negative side of the number line or the negative side of the x-axis when the value of P is negative. And it will only face towards the positive side of the x-axis, which is this side, when the value of P is what? Is positive. So for this one, the value of P is negative, which is less than 0. And then for this one, the value of P is greater than 0. So same applies to this. If you want to master it well, you can say when it's facing towards the positive y-axis, the value of P is what? Is positive, meaning it's greater than 0. And then when it's facing, you know that it's facing towards the negative y-axis when the value of P is what? Is negative, meaning it's less than 0. That's what it means. Okay, I don't know if you have any questions. Let's move on. So let's look at the types of parabolas. I think I've explained this, so let me just run through it quickly. All right, so this is what I was talking about. So you have, this is a parabola facing up, and this is its equation. Since the value of x is the one that is squared, so you expect it to either face up or down. And in this case, when you look at P, when you look at P is positive, so you expect it to face up. So here, I was supposed to add a negative this side, or I think just this information down is enough. You can just say, since P is what? Is less than 0. Then when P is greater than 0, it will face up. So as you can see, it's facing up. There it's facing down because the value of P is considered to be less than 0. Here, the value of P is considered to be greater than 0. That's why it's facing towards the positive x-axis. And then here, the value of P is considered to be less than 0. That's why it's facing towards the negative x-axis. Okay. Let's quickly look at this example here. All right, so this is a very simple example. So it's a very simple example. Let's quickly go through it. Okay. So this example says, find the equation of the directrix and the coordinates of the vertex and the focus of the parabola given by the equation 3x plus 2y squared plus 8y minus 4 is equal to 0. So this is a very simple equation. The first thing that you need to do is to complete the square of this equation. So we have 3x plus 2y squared plus 8y minus 4 is equal to 0. So this is what you have as your equation. So the first thing that you do is you take the independent variable to the other side of the equal sign. That's what you do. You take the variable which is okay, let me just say, you leave the variables which are existing 2 times. Okay, you can see that we have 2y values, or 2y terms in this case. We have this one and that one. So these are the ones that you leave on the left, and then you take the remaining numbers to the right. So, or the remaining terms to the right. So we'll take this term to the right. We'll also take this -4 to the right. So we are going to have 2y squared plus 8y. Then this will be equal to, so when you take 3x to the right, you're going to have -3x. Then you are also taking -4 to the right, meaning you are going to have +4. So immediately after doing this, you quickly complete the square of the remaining terms on the left. So how do you do that? So let me just write it properly to create more space. So we have 2y squared plus 8y is equal to, so we have 3x, -3x, and then we have plus what? Plus 4. So completing the square of this term here, completing the square of these 2 terms there, the first thing that you do is, if you want, you can divide everything by what? By 2. Or you can simply just factor out a +2. Yeah, but the simplest way to do this, just divide everything by 2. So when you divide everything by 2, you're going to have y squared plus 4y is equal to -3 over 2x. -3 over 2x plus what? Plus 4. Then after dividing everything by 2, the next step that you do here is you find half of this term here. So you find half of this term. So you're going to have y squared. Half of +4 is what? Is +2. So half of +4 is +2. So I'm going to square this, and then I'll say minus the same +2 squared. Yes, Cecilia, you have a question? Plus 4y.
Yes, sir.
Okay.
Why didn't we divide what's this 4 by 2?
Oh, sorry. Thank you very much for that. It was just it's supposed to be 2. Okay. So this other side will remain with what? Remain with -3 over 2, then x there plus 2. So the next step that you do here is to complete the square of the first 2 terms there. So what you do is you put them in brackets. You have 1 plus 2 in brackets. Then you say this is squared. And then minus 2 squared will give you what? Give you 4. Then you forget this, you omit this from the equation. Then you're going to say this is equal to -3 over 2 plus, x plus 2. So I'm going to take this -4 to the other side of the equal sign. So when I take -4 to the other side of the equal sign, this is going to be y plus 2. It's going to be y plus 2 squared is equal to -3 over 2, then plus 2 plus 4. So 2 plus 4, this one will give us 6. So say plus 6. Okay. So now, after doing this, there's supposed to be x here. Remember the general formula of a parabola. Of course, this one is the one that is squared is y. So the general formula of a parabola, which has y squared, is y plus or minus k. Sorry for that. The general formula is y minus k squared is equal to 4p, open brackets, x minus h. So this is the general formula of a parabola which has y squared. Okay. So now we always have to leave x in brackets, and it's always supposed to have the coefficient 1 this side. Always. So when you reach this stage here, what you need to do is to make sure that x remains alone. It shouldn't have any coefficient there. The coefficient should be 1. So now how do you do that? So we factorize negative 3 over 2. So we're going to have y plus 2 squared being equal to, when you factorize negative 3 over 2, you're going to have x, x minus 4 in brackets. I don't know if you have understood how I've come up with this 4. So I know to say if I multiply negative 3 over 4 times this negative 4 there. Oh, sorry, this is negative 3 over 2. If I multiply this negative 3 over 2 times 4 there, or let me just put it this way so that you get the point properly. So in other words, if I multiply what is outside the brackets to what is in the brackets there, I'm supposed to get back to this expression. So if I multiply this and that, this should give me, should take me back to this expression. So negative 3 over 2 times x will give me negative 3 over 2x. Then negative 3 over 2 times negative 4. This is going to give me what? Plus 2 into 4. That's 2 into negative 4. That's negative 2 times negative 6. That will give, or rather times negative 3. That will give me positive 6. So I've gone back to that, which tells me that what I've written here is what? Is correct. Okay. So let's quickly move. Okay. All right, so the next step now, we find the vertex. Find the vertex, the directrix, and the focus. Then finally, we're going to sketch the graph. So to find the vertex is simply just a turning point. So the turning point is the point at which the curve turns. Yeah, so this is found by just equating what is in the brackets there to 0. So when you equate y plus 2 to 0, you also equate x minus 4 to 0. This here on the first equation, you find the value of y to be negative 2. When you take negative 4 to the other side of the equal sign, you find the value of x being equal to what? Positive 4. So the vertex or the turning point is simply just 4, negative 2. So that is the turning point. And then the other things that we are supposed to find, the line of the directrix, and then we're also supposed to find the focus. Yeah, so how do you find the focus and the line of the directrix? So the first thing that you need to find before you find those two, you have to find the value of P. Remember, the general formula of the equation is y minus k squared is equal to 4p is, 4p multiplied by x minus what? Minus h. So we have to find this 4p. So the part which corresponds to 4p in this equation here is simply just this part here. Negative 3 over 2 is the one that corresponds to 4p. So I'm going to equate negative 3 over 2 to what? To 4p. Then when I divide everything by 4, I'm going to get p as negative what? Negative 3/8. So the value of P is negative 3/8. So the simplest way now to find the directrix and the focus is to first do a sketch of this equation. Yeah, so this is going to be my XY plane. And when you look at this, equation, when you check the value of P, the value of P is simply negative 3/2. So in this case, P is what? Is less than 0. And we know that Y is squared. So when Y is squared, we expect the curve to either face this side or this other side. But since the value of P is less than 0, meaning it's facing towards the negative side, so we expect our curve to be like this one here. And then let us locate our turning point. Our turning point is the vertex, which is 4, -2. So we're going to have 1, 2, 3, 4. So we have 4 there, and then we have 1, 2, -2 there. So we have 4, -2 there. So this is our vertex. So we are expecting our curve to come out like this. So after finding this, now it's easier for us to find the line of the directrix and also the focus. So the focus is somewhere inside the what is the curve, and then the directrix is outside the curve. So how do you find the directrix and the focus? You simply just add and subtract the value of P to either the value of K or the value of H in the vertex there. So we know that the vertex is simply just H, K. So depending on the curve that you've been given, you need to know how or where to add the value of P. Is it on H or is it on K? So now, since it's in the X, in the X, it's facing either to the in this case, it's facing to the left. So since it's in the X-axis, it's facing to the left, meaning you are going to add the value of P to the value of H, which is the X coordinate. So in the X-axis, we know that the value of K, which is the Y coordinate, is constant. Cecilia, you have a question? Okay. So saying, since it's in the X, it's directed along the X-axis, meaning we're going to add the value of P to the X coordinate, which is H. So in this case, the X coordinate we have is 4. So we are going to add 3/8 plus 4. So when you add this, you're going to get so when you add this, the value of P is okay. So when you add this, you're going to get 8 times 4. This is what? This is 32. 32 plus 3, you get 35/8. So you have it somewhere there. So this will be 35/8. So our directrix will be there. So directrix, this is a line. This is just outside the the curve. And it's equidistant from the vertex, and to the focus. So the focus will be found by subtracting 3/8 from 4. So when you subtract 4 minus 3/8, the answer that you're going to get, so you're going to have 32 minus 3, that is going to give you 29/8. So this is our focus. So 29/8, I'll approximate it to be somewhere there. So I'll say my focus is here, which is F. So F will be 29/8, the value of K does not change, so we have -2. The vertex here will be the same 4, -2, and then the directrix there will be is 35/8, -2. There's a question. Let me just check it out. So where has the negative sign gone on 3/8? So it's a question. So this sign is just there to help you know the direction of, this one is there to help you know the direction of the curve, whether it's facing this side or this other side. Yeah, you can take it that way. Or if you want, you can say, to find the directrix and the focus, you add and subtract the value of P to the x coordinate if the curve is in the x-axis, and to the y coordinate if the curve is in the y-axis. So in this case, it's in the x-axis. So if we say negative 3/8, okay, if we say, let me do this. If we say 4 plus or minus negative 3/8, let's see what you're going to have. But this is still not making sense. Okay, so this negative is just take it the way I've told you. This negative is just there to give you the direction of the curve. But when subtracting and adding it to the x coordinate, in this case, you don't consider it. Just say the x coordinate minus 3/8, the x coordinate plus 3/8 to find the directrix. That's how we do it. Okay, so that's how you take it. So you should always just forget about this. This one is just there to help you find the direction. Okay. So let's quickly, I think we're done with this question. I don't think there's anything that we're supposed to do. So found the focus, we find the directrix and the vertex. So now how do you find the line of symmetry or the axis of symmetry? So this one is straightforward. Just get the y coordinate in this case. So if you have a curve which is like that or like that, you get the x coordinate. But in this case, since we have a curve which is like that and that, which is facing this side, it's along the x-axis, you get the y coordinate. So in this case, the axis of symmetry is y is equal to -2. Just get the y coordinate of the vertex. Yes, Cecilia. Cecilia, I have a question.
Yes, okay. Maybe I'm not understanding.
Okay.
For us, this for finding the I don't know if it's the directrix. It's the x coordinate plus the value of P.
It's a good question. So that's why I told you to say before you start finding the directrix and the focus, make sure that you draw something, you sketch, so that at least, because let's take, for instance, you have a curve which is facing this side. Are you also going to subtract when finding the focus, or you're going to add? Because if you're going this side, you expect yourself to add the value of P to this point which you have there. If you're going this side to find the focus, in this case, we subtracted to find the focus. But when you have the curve which is facing this side, you eventually do add to find the focus. Here we subtracted to find the focus. Here you're going to add when you have the x axis like this. Then to find the directrix, if it's, for instance, this side, you are going to subtract the x coordinate. You're going to subtract the value of P from the x coordinate to find this value there. So it's not always that you add, subtract.
So it depends with what's this, where the curve is facing.
Yes.
This is facing.
Yes, that's why I said first draw something so that you, at least it guides you. It will guide you about where the directrix is going to be and where the focus is going to be.
But why is this curve like facing this side, left, right, not upward and downward?
Because the value of y is squared. When x is the one which is squared, if we had something like this, squared is equal to, then you have some figures this side. Then you expect it to face up or down.
All right.
Yeah, so that's the secret there. Just check the variable which is squared. So if y is squared, you expect it to either face this side or this other side. And then if x is squared, it will either face up or down.
All right, thank you, sir.
So let me just show you what I was doing. So this is what I was just trying to show you. Okay, so let's quickly do another example. So we have this example, which is also a very simple example. For this one, there's no need for you to start completing the square. It's already in the format. Yeah, but when you look at the time there, the Zoom meeting is telling us that we're just remaining with 1 minute. So let me just end the meeting right now. Then you quickly join using the same link so that we continue. We'll come and start with this question here.